Great.
This
Thanks.
conference will now be recorded.
Welcome. My name is Jim Lee. I'm the inventor of dry hydrogen peroxide technology. I'm the founder of Synexus. I'm also a former military engineer. West Point graduate, chemical engineering from the University of Virginia. Medically retired as a major while teaching at the academy. Looked for something to do, became an anti-terrorism consultant for Fortune 500s, and that led to the design of this particular system.
Thanks, Jim. We're excited to talk to you today and talk to you about our innovative disruptive technology, DHP. So I'm the CEO of Synexus. I've been here since 2015. I've got a background in medical devices, so I've commercialized many different technical products and offerings in different markets, and was brought on to expand and commercialize this into many different markets that we'll talk about. So I've got over 20 years experience in the device market on the medical side. So you're going to find that we're different than a lot of companies. We actually started out as a medical, kind of driving this as a medical device company, meaning that we've set the bar, we think, in this space for data and research and peer-reviewed data that we'll talk about. So Synexus has been wildly successful, even pre-pandemic, and we'll talk about a lot of the businesses that we've provided safe, natural solutions to clean their environments.
Okay, this is the abstract that you all signed up for. Basically, this technology was designed as a replacement for ozone. It was also designed to fill a major capability void, that void being the fact that we could not detect a bioagent in real time. The only thing it can detect is ATP fluorescence, and you can't tell if it's pollen or a pathogen. So we're looking at continuity of government, workforce protection, and the other things that are important, like facility resilience. Next slide, please. Okay, so what is dry hydrogen peroxide? Everybody's heard of hydrogen peroxide. At home, you've got it in your medicine cabinet. It's 3% solution. It's aqueous material. Hydrogen peroxide had never existed other than as an aqueous substance before we developed dry hydrogen peroxide. The way we did that, we used an older technology and then advanced it to the next stage. Basically, photocatalysis, with which you're familiar, probably, makes hydroxyl radicals from water molecules, but doesn't, and the hydroxyl radicals are halves of hydrogen peroxide molecules. The problem is they're so delicate that they're immediately destroyed in the plasma and they never get emitted to the environment. We figured out what forces were preventing hydrogen peroxide from being emitted to the environment, what was destroying the hydrogen peroxide in these older devices, and then we redesigned the technology to prevent it from destroying the hydrogen peroxide. And that allows us to emit hydrogen peroxide in the true gas phase, individual molecules behaving as a near ideal gas, spreading out into the environment and behaving throughout the environment itself. It can work in any indoor environment, and as Eric will tell you, gets into the commercialization side of things, he'll explain many places where we're now operating. Next slide. Okay, so how are we making it? As I mentioned before, you take, photocatalysis takes water molecules, breaks them into a free electron, a proton, and a hydroxyl radical. Most of the time, those three pieces just come right back together, become water. Or if two of the hydroxyl radicals get together to form a hydrogen peroxide molecule, then the electrons and the protons attack it and turn it back into water, basically. So we looked at all of the factors that were making that happen, and we worked it out to where we could separate the hydroxyl radicals from the other components of the plasma. And by basically separating the plasma the way you separate an egg, we're able to create a zone that just contains hydroxyl radicals. And in that hydroxyl radical zone, we're now able to create hydrogen peroxide as a true, dry, non-aqueous, near ideal gas. And then, of course, the free electrons and the protons have to go someplace. They reduce oxygen molecules to yet more hydrogen peroxide. Electron proton gives you a hydrogen. Another electron proton gives you a hydrogen. Pop them on each end of an oxygen molecule. You've got another hydrogen peroxide molecule. Next slide, please. Okay. Left the military, as I mentioned, a little earlier than I expected, due to celiac disease. Got out in '97, worked for a government contractor for a year as a licensed professional chemical engineer. Wasn't really happy with that career path. And then the African embassy bombings hit in 1998. I looked at that and I said, that could just as easily have been something nastier, and it could have been directed against private corporations. Did my research. I found out that most anti-U.S. attacks at that point in time were actually directed against private corporations. So I threw out a shingle in 1998, 3 years before 9/11, and started marketing myself to the major industrial security companies as an engineer with specialty in chem, bio, radiological defense. That led, I dealt with an anthrax letter that was targeted at the world's largest software company. From one Fortune 500 to another after that, the NYPD found me, brought me into the city to help explain facility vulnerability reduction to private security officials throughout the city. And then within a year, I was consulting full time for the world's largest insurance company. As a private corporation, were putting the first sensor networks in downtown Manhattan, New York, we encountered that capability void. We could detect chemical and radiological in real time, but not bio. So we needed something that would be operating prophylactically in an environment, would be operating 24/7, 365, would be continuous, would not be ozone because ozone is dangerous, and would be safe enough to use full time around people, and would begin mitigating a bio risk from the moment of its introduction, even if its introduction wasn't recognized. That led to the development of this technology. It led to the filing of the first patent and the founding of this company. And then that first patent ended up being granted in 2012, and we've expanded from that point. Next slide, please. Okay. So I don't know if you can see this next slide.
Did the slide change? I'm sorry.
It did not. Are you seeing a sinusoid? Are you seeing a couple of graphs on the?
Yes, we are.
Continuous mitigation.
All right. Okay. So what people were mostly familiar with are registered disinfectants. Synexus is regulated by the EPA as a device technology in the same way that and the EPA also regulates pesticides. There are two different. They regulate us slightly differently than they do the pesticides themselves. On the left side of the screen, what you see is what you get when you're using a registered pesticide. And basically, if you're in a hospital or any other facility, and if you're in a hospital or any other facility, and you're using these pesticides on a regular basis, you take a dirty situation, you bring it down to a clean situation, and then you can't use that full time, and you can only use it on surfaces. And so it gets recontaminated. And basically what you have is a sinusoidal behavior where it keeps getting, it gets dirty, you clean it, it gets dirty, you clean it. And somewhere in between the high points and low points is that median, and that represents your baseline, biocontamination level for the facility. When you combine our technology with EPA registered disinfectants, what you get is a synergistic effect that's very powerful. Remember, our technology works in the air, so we're killing microbes in the air at every point in the room at the same time. We are also killing microbes that are on surfaces in contact with the air. So we're impacting the surface that's normally cleaned in between cleanings. We're impacting the surfaces that are intended to be cleaned and might get missed, and we're impacting those surfaces that never actually get cleaned, which act as contamination reservoirs. And what you get when you combine our two technologies is the profile that you see on the right, where that baseline bioburden changes. You go from that steady state that you would have on the left-hand side to a new steady state on a permanent basis, and it's generally about 99% less than it is without, when you're just using EPA-registered disinfectants alone. We've tested against every class of organism, obviously not every organism out there, but we are effective against viruses, both enveloped and non-enveloped, against bacteria, both vegetative and spore forming. We're effective against fungi, mold, both vegetative and spore forming. We've used our technology in a wide variety of venues against all of these different types of organisms. And in our testing, a lot of companies will go out there and they'll put their device in a very small chamber. And the result of that is they get good results because it's in a very small chamber, but you can't extrapolate that data honestly into larger environments. So though we might do a proof of concept test at some point in a small chamber, in our controlled testing, we go into larger room-sized spaces that are representative. I mean, you put our device on one side of the room, we're killing things on the other side of the room with it. And then, of course, we've got a wealth of data from our clients throughout all types of industry showing how our technology actually works in uncontrolled real-life situations. Okay. All right, so our capabilities. As I mentioned, the dry hydrogen peroxide is completely non-aqueous. That's very important because normally, hydrogen peroxide is aqueous, right? That means that the polar hydrogen peroxide molecules are surrounded by polar water molecules, and the polar vulnerable structures on a microbe are surrounded by polar water molecules. And those water molecules get in the way. They're an inhibitor. They limit the action of the hydrogen peroxide, and you've got to increase the concentrations of hydrogen peroxide when you're using aqueous forms of it. When you use dry hydrogen peroxide, there's no water to get in the way. So the hydrogen peroxide has direct access to the polar structure that you're attempting to denature on a microbe, and it acts at much lower concentrations and very effectively. We generally operate at about 10 parts per billion. I'll talk a little bit more about the concentrations in the next slide. But at 10 parts per billion, which is just 1/100th of the OSHA safety limit, we are still placing in every cubic centimeter of air 250 billion molecules of dry hydrogen peroxide. And what that makes our technology is a point of risk countermeasure. That means that as a microbe is moving through the space, it doesn't have to go to an air return and then through a treatment system, or it doesn't have to go to an air purifier and be treated in that air purifier. As it is literally transiting the air, it's encountering dry hydrogen peroxide in every cubic centimeter of air. And imagine a submarine in World War II trying to move through a magnetic minefield, because these hydrogen peroxide molecules are actually polar, and as soon as they get within the attraction distance to those structures on the microbe, they start closing in on it and they do damage. And they also do that to volatile organic hydrocarbons. So we take care of odors. And one of the things we found is even though this hydrogen peroxide is safe for us because we have lung enzymes that deal with hydrogen peroxide, insects and arachnids don't. So they don't like it. And the neat thing about our technology with regard to mold is you put it in, we get rid of the odors immediately, we kill the mold over the next day or two, and then it never comes back as long as our technology is in place. That means you don't have a recurring mold problem every couple of years. We're effective against SARS-CoV-2. We've been tested at the Biosecurity Research Institute at Kansas State University on surfaces. We got 98.7% reduction after 2 hours. We've also tested against a SARS-CoV-2 surrogate for airborne testing. That's the Ms2 bacteriophage. It's a recognized surrogate. We got 99% reduction in 1 hour in the air. Next slide, please. Okay. So safety, this is a key thing about the technology. As I mentioned, we're operating generally at 10 parts per billion. At 10 parts per billion, we have 1 molecule of dry hydrogen peroxide in every 4 cubic microns of air. Now, 4 cubic microns is interesting because that's exactly the size of a microdroplet you get when you vaporize an aqueous solution to create an aerosol of droplets in the air. And if you look at on the far right, you've got what you've got in your medicine cabinet, that aqueous 3% by weight solution. If you have a 4 cubic micron sized droplet from that bottle, it has 2.34 billion molecules in just those 4 cubic microns. So I can look at that and I can say that we are basically 234,000 times less concentrated than the solution you've got in your medicine cabinet. Now, I mentioned our lungs. Our lungs have 3 enzymes that control and regulate hydrogen peroxide. You got 2 enzymes that make it all the time, 24/7, 365. They're referred to as a Duox compound. A third one, lactoperoxidase, uses the hydrogen peroxide to create an even more powerful antimicrobial compound. So there are 2 things here. What this means is that hydrogen peroxide is a necessary component in our lung defense. And it's also a natural and, as I said, necessary component of our lung chemistry at the right concentration. The literature reports a 10 to the negative 6 molar equilibrium concentration in our lungs. That concentration is 2,400 times more concentrated than what we put in the air. So, that is the basis of our safety claim. Next slide, please.
So when I first met Jim in 2015, I didn't know what a molar was. I didn't know what parts per million necessarily was, even though I was a medical device person. But I was used to data, and I looked at Jim and I said, if this does what you say, this is transformational, and we got to prove it. So that's what we did. So it's probably important to level set everybody from a commercial standpoint as to how we've got here. We've got over 35,000 units right now that are operating in multiple different applications. But we did our first commercial product, which was called the Blade, in and about 2013, and really started to commercialize that in 2015 after doing some pilots after I started. But the real innovation here is what Jim said. And when I was doing diligence and looking at the market, I looked at it from a data standpoint. I looked at it from a differentiation standpoint. And what I realized pretty early on was that there's not a lot of regulation in this space. Secondly, there's not a lot of data. There still isn't, outside of Synexus, a lot of data validating different technologies to the level of scrutiny that we hold ourselves to. So it's important to realize that we set out to do the right thing from a data transparency standpoint, many years ago, and not many months ago, trying to capitalize on a pandemic. And ironically enough, what Jim invented and the military aspect of this is very relevant to what's going on now in terms of the pandemic. Obviously, we didn't know that, but this was a system that was really invented for such a situation. So what's helped us is not only our data and being able to show the data and differentiate ourselves, but also there's an education going on right now in indoor air quality, and people are getting educated on different technologies and up to speed. And that actually is very, very beneficial to us as we've got this data-driven platform. So then in and around about the time I started, after having the Blade and doing some pilot installations, we came out with the Sentry, which allowed us to expand into more industrial markets. So this is a larger device, covers more square foot in terms of treated area, but it's the same technology. It has a bulb, has a catalyst. The difference is it has an onboard fan. And then we began to look at, okay, we have the lab data that Jim spoke about, and I do want to emphasize the fact that there's a couple criteria that are important to note. I'm sure a lot of you will be making decisions about your facilities, or maybe you're already in a position to make those decisions or influence those decisions. And it's important. The first thing is, and we'll talk about a couple more here in a few slides, but the first thing is the data not only in a larger chamber, but does it account for the natural die-off? That's important. And then as we move into 2017, we began to get some really good data, real world lab data. And now we want to take the next step and provide a data that is peer reviewed. So could we do a trial, whether it be in healthcare, animal health, two spaces that we have peer reviewed papers, and could we replicate this data in a space and statistically power it in a way that would pass the muster of a peer-reviewed board? And that's happened. So we have 6 peer-reviewed papers that are published on the efficacy of our devices, and that's around the Sentry. It's around the Sphere. The Blade, and also the Sphere, which we launched in 2020, which is a much lighter, easier to produce device, and it's more conducive to office spaces, hospitals, things of that nature, where noise is a little bit more of an issue. The industrial unit, albeit covers more space, it's a little louder. So now we have something that's really, truly plug and play, office spaces, classroom, things of that nature. And we also started to expand and continue to expand our patent portfolio. So when you look at the peer-reviewed publications that we have, these are not insignificant. So they are statistically powered, and we anticipate 2 to 3 more of these peer-reviewed papers sometime in the next few months. But as it relates to government, continuity of government, that was the basis of this, obviously. Healthcare, there's a big play. Food service, we're in over 500 quick serve restaurants as it relates to food safety, food preservation, supply chain. We've done hotels, personal care type of beauty salons, a lot of sports, a lot of professional sports actually. And we like that because they track the sick days and health of these players very closely. So we've performed very well in that aspect. But as we are sitting here right now, you can imagine the education that's going on in the space, our differentiation with the data and the peer-reviewed studies. So we're highly focused on return to school, return to work, and that's primarily what we're working on at this moment. So we did, the way we have set our company up in terms of the data has driven us to a lot of opportunities with regard to channel partners. One is Train Technologies, who we have a commercial relationship with. And one of the things that they did, which I think brings a high level of credibility to Synexus, is they went to validate everything that we had done previously, just to confirm that what we said is true. And they did confirm that on a number of different tests. And so this is some competitive testing that was done around some of the other technologies that you might be familiar with if you're looking at this space. And again, people are getting educated on this space. And I want to point out that part of the transparency of our company is the data, but we also identify ourselves, as Jim mentioned, as a layered approach. So you got your EPA registered disinfections, that's a piece of the puzzle. You have your filtration, that's another piece of the puzzle. But if you use a normal MERV filter, so what you'll notice from the key takeaway on this slide is that we're the only technology that is impactful on the air and surfaces. But you notice the particular matter that we don't impact as much. And that's by design, because we're not turning the air over. We are simply putting DHP into the space, so it's there 24/7, 365. So Jim and I are in a space right now that has DHP. If I were to be shedding a virus, we're already in the space mitigating the risk before it gets to Jim. And we rely on the building and the normal MERV filters that would be in the building to take out the particulate matter. So the key takeaway from this slide is DHP with your normal HVAC filtration system provides high efficacy at mitigating having microbial reduction mitigation in these spaces. So let's talk a little bit about our peer-reviewed studies. We're very proud of this. And this is not insignificant. This is, in terms of the technology, it is very disruptive. In terms of the intellectual property that we have, we are second to none in the space. And we're approaching in terms of patents that are issued, patents that are in process, nearly 200 of these types of patents around the application of DHP in different spaces. And so when you look at what we've accomplished so far on the peer-reviewed side, these 6 peer-reviewed papers, 4 of them are around, the healthcare space. Some of them are around reduced mold. Some of them are around reduced microbial loads in the air and on surfaces in these space. And we have something in animal health, which I think is important. So you talk about animal health and human health have some comparison for sure when you're looking at studies. But we were able to remove formaldehyde, which is a well-known carcinogen in these animal health facilities, and also increase the health and weight of, in this case, of hatchlings of birds, and they got to market quicker. So if we look at, just drill down a little bit on, summarizing a few of these that I think are very important to differentiating our technology from a data standpoint. One is just the rigor that we have for lab testing as it relates to SARS-CoV-2. So we were a little bit late, I would say, in terms of, some other companies were doing a lot of COVID testing in very small chambers, and we're rushing that data out to people. In my opinion, that's not real world. And most people look at that now as they get educated and realize, hey, this isn't a real scientific study. There's no natural die-off. This is not indicative of a real world situation. And so we wanted to, again, be different. So what we did was we did a SARS-CoV-2, COVID-19 test on hard surfaces. I realize that, most of this is transmitted in the air. We'll talk about that in a second. But we also know that this is a more stringent test. So if you can kill it on a surface, what we've seen in our other data is we kill things much faster in the air. So this is the level and scrutiny of that we hold ourselves to comes across in this study, and it shows that we're highly effective on reducing SARS-CoV-2 on surfaces against natural die-off. And then talking about the airborne portion of this, so there is an Ms2 Biophage, which is a very well accepted and well-known surrogate to the SARS-CoV-2 virus. And if you look at this data, again, natural die-off, we did this in conjunction with Trained Technologies, and what we show is very high efficacy rates in a large space, real-world conditions. But the key here is this is done under good lab practices, which means that you run triplicates, and it's also done against natural die-off. And again, unfortunately, in this space, this is not common that you would get this level of data and have this type of data that follows good lab practices. So again, we're holding ourselves to a higher standard.
We should also tell them the MS2 bacteriophage is a non-envelope virus. It's orders of magnitude harder to kill than SARS-CoV-2, which is an envelope virus. So if you can kill MS2, you can kill any. The EPA basically says you can kill any envelope virus. But to kill this 99% in 1 hour shows that we can do it even faster and more easily against SARS-CoV-2 in the air.
Great point. Thanks, Jim. So the other thing to point out is, we were doing this long before COVID, and I would point out that we are not just a COVID company, and we certainly are impactful against COVID. We've proven we're impactful against COVID, but there's many other aspects of what we do. And so when you look at some of our other studies, this one in particular talks about a 65-bed pediatric oncology ward. So again, looking at this type of data in an immunocompromised group of patients where we can impact that environment and have, in a safe way and reduce the microbial loads, we think is very significant. There is a follow-up to this that we anticipate being published that's going to correlate this to reduced HAIs in this patient population. And again, we feel like that level of data will pass the scrutiny of a peer-reviewed board and will be published. And then when you look at the study with regard to bioburden healthcare facility, so now we're looking at something that's done in a much larger space. So this is multiple different departments of a hospital. This is about 120,000 square feet of treated area. It's got a baseline, a rolling baseline, and you see that we have 99.5% reduction in this space after just 1 day. So highly impactful. The other key takeaway from this is some of the areas of concern that are reservoirs for microbial contamination, in this case, which would be the curtains. So in between the beds, the curtains, we saw very significant reductions in the curtains, which are reservoirs for these contaminations. And we think, based on the people that we've talked to, can contribute to HAIs in these spaces. So further study, but we do know that we have significant microbial reduction, not only on the air and surfaces, but on specific high-touch areas such as the curtains. So we've got a lot of different deployment, what I call form factors, right? So the great thing about DHP and the way that we have, our system set up is that it's highly scalable. It can be in out of sight. So a lot of times, especially pre-COVID, people wanted things that were out of sight. They didn't want there to be a perceived problem. And so a lot of the blades were going in the duct, and these are positioned right at the diffuser level. And so as the air passes through, it continues to put dry hydrogen peroxide in the space. The one thing to point out is that you don't get a buildup of hydrogen peroxide in the space. So unlike ozone, which even at lower levels will build up over time, hydrogen peroxide by nature of structure wants to turn back into humidity, wants to turn back into water. So essentially, it has enough half-life to go in and do what Jim explained, and we've proven that multiple times in different studies, obviously. but it has enough half-life to do its job. Then it turns back into humidity and goes back through our system again. So at the blade, at the end of the diffuser, we're constantly just making the DHP, and it's doing its job and going back through the system. Then we have our sphere that I mentioned, which is highly portable, very light, about 12, 14 pounds, plug and play, can be on a table in a room. We use this a lot for, we're in literally thousands of dorm rooms at this point, a lot of classrooms, offices. So these are plug and play, very quiet, non-disruptive, and it doesn't interfere with any of the day-to-day operations of a business or interactions in a classroom, for example. And then the Sentry, as I mentioned, is the industrial version. And then, again, we're very excited about our R&D pipeline. So we have not only different form factors, but we have some things coming in the next several years that we feel very confident are going to be further transformational to this space. So finally, and then we're going to take some questions here. But what's been interesting for us as we moved into this space, and really we knew that there was a technology void in this space. Ozone is not the right answer. People are figuring out that it's not the right answer. Unfortunately, there's many companies that are changing the name of ozone to try to confuse the market, friendly oxidizers, things of that nature. Now there's what's called UL 2998, which is a new Underwriters Laboratory test that is virtually no ozone. So we hope that's where this is moving. But in my view, part of our mission here is not only to change this space in a fact-based, data-driven way, but it's to educate people. And so we want people to make good decisions. And we understand that many people on this call, as I mentioned, are going to be in a position to influence those decisions for facilities, or maybe even making those decisions. And maybe you're in a position now to make those decisions. So we put together a little list here of some things that you should ask. And does it, some of these may seem kind of obvious questions to ask, but unfortunately the misinformation leads you to dissect a few of these things a little bit more at a granular level. So does it actually do what it says? So in other words, do they have data, or does a company have data in real world environments? So, 130,000 square foot in a hospital, I think is very significant for us. The fact that it's peer reviewed makes it even more relevant. But ask that question. Do they have real world data? Are the results validated peer review? Are there published studies? So many of these, types of studies don't even pass the level of good lab practices, meaning they don't account for natural die-off, much less peer-reviewed. But you really got to know what you're looking at, and you really got to read, more than just the picture of the slide or the graph that someone might show you. Ask for the study. Ask for the full report, and they should be able to provide that to you. Is it patented? So, we've been a little bit frustrated because sometimes people will say we make DHP. We haven't found anybody that makes DHP, but we have patents on dry hydrogen peroxide. We are the sole developer of dry hydrogen peroxide, period. So we think that's a huge advantage for us. Air and surfaces. Why do you have to choose between disinfecting air and surfaces? And again, we're not just a COVID company. So, the fact that we can get to all the hard reach spaces that maybe might get missed by the intermittent cleaning, or certainly by just the natural cleaning and disinfectant practices of a place, it's pretty impossible to get to every place. So we provide that added protection in between and in those areas that are hard to reach. And does it, we don't disrupt daily operations. There's a lot of technologies. You got a wheel and a robot or whatever, and the room is very clean. What I would say to that is you took care of yesterday's problem, because as soon as that room is occupied, as soon as that, there's something in that space, the production line turns back on, whatever that is, you've recontaminated that space. So DHP, our technology, works 24/7, 365. And the other thing is you have to look at, is the data that they're presenting the same as the device that they are testing? So in other words, sometimes people will show you data from one device and then over here say, yeah, but this is ozone free and it's not the same device. So I think it's very important to scrutinize and probably even over scrutinize in this space right now. There's a lot of money out there right now for indoor air quality types of devices, and we are very proud of the fact that we are transparent, data driven, differentiated, and we'll allow people to do their own third party data if they want, but certainly we can provide them with our data. So. Anything else to add, Jim, before we talk about questions?
No, I'm looking forward to the questions.
Yeah, great. So we'd be glad to take. Also, we've just expanded our social media here, so join us on our social media: Twitter, Facebook, and LinkedIn. So at this point, if there's any questions, we'd be happy to take those.
We do have a few questions in the chat box, and I will. I'll start at the top and just read them out to y'all.
Okay.
From Austin, has it been tested against airborne respiratory fluids containing SARS-CoV-2? If so, what were the results? Provide more detail.
For airborne, we've, as I mentioned, we've tested against the Ms2 bacteriophage, which is, as I mentioned, also a non-envelope virus, which is orders of magnitude harder to kill than an envelope virus. Flu, SARS-CoV-2, all of the others that are generally the respiratory diseases are envelope viruses, which are much, much easier to kill. And the EPA, has basically said if you kill Ms2 bacteriophage in the air or on surfaces, you can also do that with a coronavirus in the air or on surfaces.
I would just add that our testing methodology, it's hard to test every organism. So what we do is we look at classes of organisms, and so we know, to Jim's point, influenza, highly susceptible to DHP and multiple different tests that we've run, and then you combine that with the peer-reviewed SARS-CoV-2 data. Then I think it shows efficacy on both of those fronts. All right, next question.
Next question from Patrice. Can you give us a sense of additional O&M costs associated with this technology?
Yeah, so part of what we do in a service we offer is, none of these installations are cookie cutter. I'm certainly not avoiding the question, but we find we fit very well into most budgets, and we've got flexible ways we can deploy the systems as it relates to fitting into your budget. But one of the things that we do is a full assessment of the space, and again, sometimes it requires different devices. So if one installation could be all spheres, for example, usually it's some sort of a combination of all three of these types of devices. And so it is very economical, but it's not a one size fits all type of situation. But we've not found that from a budget standpoint that it's been limiting for us. So it's really a case by case basis.
Next question's from Gary. Are the reduction timeframes you are achieving timely enough for real world applications? Also, are there device maintenance requirements?
The answer is yes. And I'll relate this to the nature of a test versus the nature of the real world. A test by necessity, you've got to use a lot of organisms so you can show a certain amount of reduction in a particular amount of time. So when you put the contaminant into the large room, basically it's thousands of times greater than any amount of organism that you would see in a normal environment, unless you marched in a whole platoon of people with SARS-CoV-2 and start singing, basically. But the long story short is, based on we can show a let's say a 98.7% reduction against SARS-CoV-2 on surfaces within a 2-hour time period. That's against a very, very high challenge rate, whereas the thousands of times less, and in the air where we kill things much more quickly, you've got, obviously less SARS-CoV-2 from an individual or two walking into the room.
And I'd add one more thing, and then I'll talk about the maintenance. But when you do statistically powered, peer-reviewed studies,
right,
there's nowhere to hide. So the short answer to your question, which is a good question, is that new steady state baseline is definitely efficacious and does provide a microbial reduction in a real world environment. And again, I'd point to these peer-reviewed papers because the data is the data, right? I mean, it's peer-reviewed and statistically powered, Kaplan-Meier, all that kind of stuff. So the short answer is yes. We see very, very consistent results. And what's very interesting about this, from my standpoint, is just the consistency of results. So it's going to sound kind of funny, but you can actually see the same type of trend in a poultry facility that you see in a hospital. Now, I'm not suggesting that a poultry facility is cleaner than or dirtier than a hospital, but the point is, this is shown to be highly impactful over multiple different environments, some of them very harsh. Mm-hmm. So we feel very confident about that. To answer your question about the maintenance, there is maintenance. It's quarterly maintenance. So first thing is it draws very low power. The second thing is the maintenance is pretty quick and easy. So there's a particulate filter, and then the catalyst sale, that's our proprietary catalyst, is replaced once a quarter. Thanks. Next question.
Question from David. In addition to electrical power source, what else is needed to operate?
Nothing. So keep in mind that outside of the maintenance that I just discussed, we're not adding anything to the device. So sometimes people get us confused with vaporize, which I think Jim articulated the reasons that we're not. But you don't add anything. So there's no additives. There's nothing that goes into the device. We're just processing air. So we're taking humidity that's already in the space. So in my office here, there's one in the duct, and basically the humidity level that's in this space is going through that device and creating a small amount of dry hydrogen peroxide. So there isn't, just need a plug and do the maintenance. It's a good question.
Question from John. Does this device provide outdoor air equivalents to comply with ASHRAE 62.1? If so, what percentage of outdoor air can be decreased when using this device?
Okay. So we're working with Train on some of these type of regulations. So one of the things that we're working through is that again, this isn't something that requires air exchanges. So we're modeling some things now, some more on that, in the future here when we work with Train. I will say, as it relates to using augmentation of devices such as Synexus, the criteria that ASHRAE and CDC has laid out is, the third-party data, the data in real-world environments, which I think takes into account the air exchanges that are needed. And then also the UL 2998 recommendation of no ozone. So while there's emerging devices, we don't want to get lumped into that because we have tremendous amounts of data on that. So we're keeping an eye on that, and more to come on that.
Those were all the questions that were in the chat box. Anybody else on the line have a question? Feel free to unmute as well if you would like to ask. Can you find your publications on your website? Where's the best place to find those?
Yep, they're on the website. You can also do a quick search on PubMed and type in Synexus, they'll come up, but they are accessible on our website. Thanks.
If there aren't any other questions, I'd like to thank both Jim and Eric again for your time and presenting on your expertise. It was a great presentation, really informative. Again, for those that have joined us today, the recording, slides, and PDH certificate will be on our Young Professionals page on the SAME website. If you can't locate it, feel free to send me an email and I can send it directly back to you. I know that a couple people don't have their emails on here associated with their GoToMeeting account. So it makes it difficult for me to send it directly back out to you, but it is on our website. Again, like Eric had mentioned, if there are follow-up questions or if you know anybody else who would be interested in this presentation, please send them to the recording, and then they can also reach out to our guest speakers as well. So thanks everyone for your time.
Great. Thanks so much. Have a great
Thank you.
day.